I am Orkaparna Nandi. I am a second year student of VIT Chennai. Today I am going to give a brief idea on the topic of application of context-free grammar in natural language processing. What is context-free grammar? Context-free grammar is used to generate type 2 grammar and is recognized by push-down automata. Now, this is vividly described by the right-hand side diagram over here, which explains the hierarchical order of all the types of grammar, that is type 0 to type 1, type 2, and type 3, upon which type 2 is denoted by context-free grammar. Okay, so now we shall see the various tuples which are present in context-free grammar, which is abbreviated as CFG. The tuples used here are V, T, S, and P, where V denotes the set of variables, T denotes the terminal symbols, S denotes the start symbol, and P denotes the production rule. Now, the very next question that shall come into our mind is to why do we need to learn CFG? What type of operations that we can perform in this? Why is it useful? Now, to cater all these questions, we have a next slide over here that are what are the operations performed in CFG. Now here we have enlisted the various operations that we can perform in CFG along with a detailed example of all of these so that we have got a clear idea about all the operations that we can perform in it. Okay, now let's begin. Generation of grammar from a general string. Over here, a general string, say a to the power n, b to the power n, and c to the power m. We have generated a CFG for this given string. Next, push-down automata already described in the last slide. See, we can say that for any grammar, if we can generate a PDA, then we can say then that grammar is definitely a CFG. For this grammar, see over here, a to the power n, b to the power n, c to the power m is definitely a CFG, as we can denote, or if we can describe it, or we can draw a PDA for it. Okay. Next, conversion to Chomsky normal form or CNF. Now, in this case, the Chomsky normal form, we can see that a grammar is said to be in CNF if it follows this format. That is, A gives BC or A gives small a, where A is the non-terminal, that is a non-terminal when gives two non-terminals, or a non-terminal when gives one terminal symbol, that is small a, then we can say that form of grammar is said to be in CNF. Now, the next over here is CYK algorithm and conversion to Kreibach normal form or GNF. Now, for both of these cases, we need to convert the CFG first into CNF, and then we shall proceed with these formats. So let's begin with CYK. CYK algorithm is basically a tabular algorithm. Over here, we describe or we determine whether a given string is a part or is derived from the given production rules or from a given grammar. So let's take an example over here. AB, AAB. The question is whether this string is a derivation of this given grammar, this given CFG format. Now, by following this tabular procedure, if we observe that in the topmost box, if the symbol S, if the non-terminal symbol S is obtained, that is the given string, then we can say that the given input string is definitely a derivation of the production rule. Next, we go to CNF. Next we go to GNF, that is Kreibach normal form. In GNF, the format followed is a non-terminal gives a terminal symbol, or a non-terminal gives a terminal symbol followed by infinite number of non-terminals. For both of these given formats, we can say that the grammar is said to be in GNF. Lastly, we have pumping lemma for context-free grammar. Now, upon following all these three rules, that is in the pumping lemma rule, we can say that if all of these rules are followed, then we can say that the given grammar is definitely not a CFG. That is, pumping lemma is used to disagree to the fact that a grammar is a CFG. Okay, yeah. Now we shall see the various applications of CFG. Now, here all the various applications of CFG are enlisted below, but we shall focus upon an important application, that is natural language processing, which is abbreviated as NLP. Now, What is natural language processing? Natural language processing is a branch of artificial intelligence that enables machines to understand human language. That is, natural language processing helps a machine or enables or empowers a machine to understand, to analyze, to, to derive or determine various facts out of a given sentence by a user. Okay. Now see this Venn diagram over here. We can see that these AI, ML, DP, these are one of the DL, these are one of the most common and hot topics which are present nowadays. AI means artificial intelligence, ML denotes machine learning, DL denotes deep learning, and so on. So NLP, that is natural language processing, is also a part of all of these. Okay, it is also a part of all of this, along with certain additional features which makes it very special. Okay. Now we shall see whether various applications as to why do we need to learn NLP? What are the uses? Where are they used in the common day scenario? One of the most commonly used application is the search, autocorrect, and autocomplete. Now this is very useful. This is very used. This is used every day, in every hour, in every moment when we use or when we search or we type or we message to someone via various social media services or when searching any question in Google or somewhere. Next, we have chatbots. Now, this is commonly visible in all those customer care services where these chatbot services are provided to the customers. Now, the next application, that is voice assistant. This is like to all those iPhone users like, hey Siri, and they could ask the questions, blah blah blah, and so on. Now, these all are definitely a part or a application of NLP. Now comes this grammar checkers. Now this is definitely used by all the students who check their English essay before submitting their assignments and so on, so as to cover up their all the grammatical mistakes and so on. These are definitely used by us in the college. Now, what is parsing? Parsing is basically a procedure. This is a procedure by which we can analyze the given sentence or the given data input from the user. Now, leave all this bookish definition behind. Let's focus on this diagram here. So, parsing is a procedure by which the sentence given by the user is analyzed and the meaning is obtained. And by using a parse tree, the machine can work on it, can execute, can perform various operations on it. Now, two approaches of parsing are used in common day scenario. Number one is top-down parsing. Number two is bottom-up parsing. Okay. Yeah. So now in C, now here we shall describe the various parsing rules of CFG which is used in the last slide over here. See, this parsing procedure follows a set of rules of CFG. Using these rules only, we can describe or we can find the meaning of the user input. Now, these rules are enlisted here, and all those and examples for all of these rules are given in the right-hand side. Now, leave all these rules behind. We shall understand all this by seeing the examples of the top-down parsing or the bottom-up parsing in the upcoming slides. Now, before moving on to the two approaches of parsing, let's get a brief idea about what is parse tree. So parse tree is a graphical representation or tree-like representation of a given sentence or a symbol. It follows mainly 3 points. Number one is all the leaf nodes have to be terminals. All the interior nodes have to be non-terminals. And upon in-order traversal, we get the original input string. Now we can see all these are applicable in the given sample parse tree in the next slide over here. See, in this sample parse tree, we can say that all the terminal symbols are denoted by the leaf nodes. All the non-terminals are denoted by the interior nodes. And here, the final or the topmost node is the final string that we are searching for. And upon in-order traversal, we get the required string. See, upon in-order traversal, we get the required string, that is, I prefer a morning flight. Okay. Now, we shall focus on the different approaches of parsing. The two main approaches of parsing are top-down parsing and bottom-up parsing. In top-down parsing, we shall start from the start symbol and gradually go down by following the different rules of CFG and get the required string. In bottom-up parsing, the complete reverse or the opposite is done. That is, we begin from the terminal symbols. Here, the terminal symbols are nothing but the given user input or the given string in the human understandable languages. Now we shall move up the order following again the same rules of CFG to get the required string S. Okay. Next, this is a very detailed example of top-down parsing. Over here, we observe these denote the production rules of this given parse tree. And by following these production rules, we shall describe or we shall form the required parse tree. So let's begin. We'll begin from the top, that is the given string, that is E. Now E gives T E bar. See, E gives T E bar. Now see in the next example, now here we observe that leftmost derivation or LMD is used. That is, the leftmost non-terminal symbol is derived gradually, and once this non-terminal gives a terminal symbol, then then 2 is right. The leftmost non-terminal is again subdivided to form the terminal symbols gradually. Now let's proceed. See over here, F is that is the leftmost non-terminal symbol is F. So F is again is subdivided to ID. See F gives ID, correct? Now here the leftmost non-terminal over here is T bar. So T bar gives epsilon. See T bar gives epsilon, correct? Now gradually following the same procedure, we obtain the required final parse tree. Okay. See, the required parse tree gives the final string, final input string that we are searching for upon in-order traversal, that is from left to right. See, we observe that the required string is ID plus ID star ID. This is the string that we are searching for. Okay. The next approach is bottom-up parsing. In bottom-up parsing, another different example over here is given. This is the production rule. The required input string is here. And as already mentioned above, and already mentioned in the previous slide, in case of bottom-up parsing, we shall begin from the terminal symbol, and the terminal symbols are nothing but the given string, which is given as user input, that is ID star ID. Now, in this example, we have used the rightmost derivation or RMD, whereby the rightmost non-terminal symbols are derived first to give the required terminal symbol, that is the string. Okay. So ID is denoted is obtained from F. See, ID is obtained from F. That is, in this case, we proceed backwards. We proceed backwards or up the ladder such that the required string, that is E, is obtained. Okay. See, the required string over here, the E is obtained. Now we shall see an important flaw, a very important flaw that is obtained, or that is encountered when following this parsing procedure. This flaw is nothing but ambiguity in the parse trees. Now what is ambiguous? What is ambiguity? Now a grammar is said to be ambiguous if for the given same string or for the given same sentence, we can obtain more than one parse tree by following the same grammatical productions of the same grammar rules. Now for this string, let's say I shot an elephant in my pajamas, we see that two different parse trees are obtained by following the same grammar rules. Hence, we can say that this string is a ambiguous string, or this grammar is said to be an ambiguous grammar. Now, this is a very common flaw that is encountered by following this parsing procedure. Okay. Now, in this video, we have learned all these concepts that is summarized in this one slide overview. Let's begin. In the beginning, we have learned about the context-free grammar as to what is context-free grammar. That is, it is a type 2 grammar recognized by push-down automata. And NLP, that is natural language processing, is an important and notable application of this CFG. Now, NLP is an NLP, that is natural language processing, uses the method of parsing to analyze, to determine to work on the given user string, and it follows two procedures, that is the top-down parsing and the bottom-up parsing. An important flaw to this parsing method is ambiguity. A grammar is said to be ambiguous if it follows more than one, if there exists more than one parse tree for the given same input string by following the same rules of CFG. Okay.